Welcome to Astrum, where we delve into the mysteries of the universe and explore the latest scientific discoveries. I'm Alex McColgan, and today, we have a fascinating topic to discuss. Oumuamua is gone now. It is past Neptune's orbit and is far enough out that no telescope can study it ever again. Its origins and nature remain a mystery that still stokes hot debate in the academic community to this day. Was it a fragment of a broken planet, flung our way from a distant star? Was it a piece of alien technology, either accidentally or deliberately sent to our solar system by an enigmatic intelligence? Surprisingly, or perhaps unsurprisingly, there are still academics who put forward both theories as plausible. Oumuamua's anomalous nature makes it difficult to classify as either a comet, an asteroid, or something artificial. But it might be important to reach such a classification, as 6 new objects have been detected in our solar system that share Oumuamua's most bewildering trait, its ability to accelerate, with no clear explanation for where such acceleration is coming from. I'm Alex McColgan, and you're watching Astrum. And today we will be exploring Oumuamua, and these 6 new fittingly named dark comets, and exploring the theories that have arisen in the last few years as scientists attempt to explain something that has so far defied clear explanation. As a quick recap, Oumuamua is the first recognized interstellar object to arrive in our solar system. It did so on the 19th of October 2017 and was spotted by the Halakala Observatory in Hawaii. Scientists quickly noticed that there was something strange about this object. It was small, perhaps between 100 and 1,000 meters long, and was believed to have an unusual shape, perhaps a cigar or a flat dish. Its trajectory and speed made it clear that it would eventually leave our solar system, so scientists reasoned that it must not have come from here. The object was thus given the Hawaiian name Oumuamua, meaning scout or first distant messenger. As the first of its kind that we know about, although admittedly definitely not the first interstellar object to pass through our solar system, as there are trillions of possible candidates out there that likely have done the same, scientists were excited to study Oumuamua, to learn what characteristics it might have that made it similar or dissimilar to objects found in our own solar system. As they did so, they began to notice certain abnormalities. While Oumuamua was initially classified as a comet, it became apparent that Oumuamua lacked a coma or cometary tail, making it more similar to an asteroid. However, this lack of coma became a puzzling issue when Oumuamua was seen accelerating away from the sun on its slow way out of our solar system. The rate of acceleration was minor, only about 17 meters per second when it was nearest the sun, and yet this was enough to cause a stir in academia. Oumuamua was not doing what physics said it should do. In the few months scientists were able to observe it, Oumuamua was deviating from its path. In physics, objects can only accelerate when they are pushed. And so, scientists began to try and explain what was pushing Oumuamua. A few initial hypotheses were quickly ruled out. This did not seem to be simple solar winds giving a small nudge. While it is a recorded phenomenon for the small trace particles fired off from the sun to push at objects in space, this small force was not enough to explain Oumuamua's acceleration, assuming it was an ordinary asteroid. I should note that this is an assumption, as even the best photos of Oumuamua only show a tiny speck, making it difficult to say for sure what it looks like. Most theories about its shape come from the variations in its light curve, the brightness of which rose and fell uniformly as Oumuamua traveled. This wouldn't happen for a round object, but would happen for a tumbling, irregularly shaped object like a disk or a cigar. Scientists reached for another example in our solar system of accelerating objects: comets. As comets travel close to the sun, the ice within them warms and sublimates, turning into gas and spouting off from the comet's main body. This outpouring of gas and dust forms the comet's signature tail, but it also gives the comet a little push, acting like a little thruster on the side nearest the sun that accelerates the comet away from the source of all that heat. But as I mentioned, scientists could not detect all that dust and gas. They looked, but it didn't seem to be there. This absence gave rise to more exotic theories. Let's take a look at an argument between two theorists, with two theories. The first theory was the most headline-catching. Harvard professor Avi Loeb promoted in numerous papers that Oumuamua could represent alien technology. He argued in 2018 that solar winds could provide the acceleration seen with Oumuamua, but only if Oumuamua was actually much thinner than scientists originally assumed, between 0.3 and 0.9 millimeters thin. As a 1,000-meter-long 1-millimeter-thin object was unlikely to appear in nature, Loeb argued that this had to mean it was artificial, a light sail, created to catch solar winds and use them to accelerate through space from one star to another. This theory met resistance from other members of the academic community. Darryl Seligman, our second theorist, and a postdoctoral researcher at Cornell University, countered by co-authoring a paper in 2020 that said that perhaps the reason no outgassing was detected from Oumuamua was because Oumuamua was emitting an invisible gas, such as hydrogen. This would not have been detectable using the telescopes that were trained on Oumuamua. Seligman proposed that Oumuamua was entirely or largely made of such hydrogen, a hydrogen iceberg, that was sublimating thanks to the warmth of the sun, and it was that sublimation that was creating the push. Loeb disagreed. A few months later he co-wrote a paper asking where exactly this hydrogen iceberg could have come from. He showed mathematically that the starlight in the interstellar vacuum was warm enough that any hydrogen iceberg that formed in even the nearest dense molecular clouds would have melted before they got here. Loeb was still convinced that an alien explanation was the most probable. His refutation was strong enough to send Seligman back to the drawing board, who dropped the hydrogen iceberg idea. However, Seligman continued to play around with the idea that Oumuamua had been moved by escaping pure hydrogen gas. Initially, he didn't have an explanation for how this could be, until in 2023 he met with University of California assistant professor Jennifer Bergner, who pointed to experiments in labs where water ice in extremely cold conditions hit with radiation could trap pockets of hydrogen, only to release it later when warmed up as the ice structure rearranged itself. As it happened, water ice is much more plentiful in space, and so is radiation. Cosmic radiation could be enough to provide the pre-baking that would be needed. Between the two of them, Seligman and Bergner wrote a paper arguing that Oumuamua needed a new category entirely. It wasn't a regular comet or an asteroid, but rather a dark comet, one with a coma that was invisible but present. Their explanation accounted for Oumuamua's acceleration, and also for the lack of dust, as dark comets would not need to release dust as they were simply reconfiguring their structures and releasing the pockets of invisible gas, rather than blasting gas from out its surface like a small gassy volcano. While this was not enough to convince Loeb, who co-authored 2 more papers in the next month that accused Seligman of bad maths, while also continuing to push his alien spaceship model, Seligman was already considering the next step in his own logic. He began to wonder, if Oumuamua represented a dark comet, could there be other dark comets out there? He, Bergner and others began poring through the data of objects already existing in our solar system. They might not be interstellar, but was anything else in the solar system accelerating when it shouldn't be? Sure enough, they found 6 that matched their criteria. 6 objects that showed non-gravitational, non-solar wind-based acceleration that couldn't be explained by any known mechanism. These objects were small, some as tiny as just 3 meters across. They looked like asteroids and didn't have remarkable features. They were near-Earth objects, all orbiting close enough to Earth that missions to them were extremely viable, and they were all exhibiting signs of acceleration. To be clear, such acceleration was very minor, small enough to have been overlooked previously. These objects aren't zipping around the solar system from planet to planet like spaceships. They are not interstellar objects. But just like Oumuamua, science cannot currently account for their motion, especially given that they do not have visible signs of outgassing, and intriguingly, one of them is already scheduled to be visited by 2031, 1998. KY-26 is due to be visited by the Japanese Hayabusa 2 probe, an asteroid sample return mission that was launched in 2014 and finished its primary mission 6 years later, but since has been given a mission extension to visit other asteroids in the near-Earth Apollo group. 1998 KY-26 is rotating quickly, once every 10 minutes, and Hayabusa 2 will aim to perform a flyby to learn more about this water-rich tiny object for the benefit of future human missions to Mars. Once it's there, perhaps it will become clearer what the source of 1998 KY-26's strange acceleration might be. It's still not obvious who among all the various scientists out there is right about Oumuamua. Given that it's now out of our reach, perhaps we will never know. But it's undeniably intriguing that more objects exhibiting strange acceleration have been detected, and highly likely that they will shed further insights into Oumuamua's possible nature and origins. If they are found to accelerate through invisible outgassing of hydrogen, Seligman will stand validated. But if a little hatch opens up and a small alien form peeks out to wave at us, before accelerating off out of the solar system, then we might regret not listening more closely to Loeb. I think the former is more likely than the latter, as there is no way 1998 KY-26 is a light sail. We have excellent imaging of this one. But either way, it will be fascinating to study. Of course, in the end, it might prove that neither theory is correct. That is the wonder of science. The more we explore the universe, the more we encounter strange and unexpected phenomena, and as we learn more about them, the better our theories become. Perhaps one day, we will encounter more objects like Oumuamua from outside our solar system, which may lend further weight to a particular explanation. The search, even for dark objects that currently act under invisible forces, always fills me with a marvelous curiosity. Once 2031 rolls around, perhaps that itch for answers will be scratched. Or perhaps we will be simply faced with more questions. Only time will tell. Can you throw a ball powerfully enough that you could turn around and catch it as it came back to you from the opposite direction around the world? This somewhat tongue-in-cheek question is actually a valid thought experiment that lets you explore some interesting quirks about Newtonian laws of gravity for objects in orbit. Perfect if you want to catch out any dark comets that are behaving unusually around our sun. The sponsor of today's video, Brilliant, posed this idea to me in their course on gravitational physics, and I was once again impressed by its simple and engaging user interface, and the intuitive way Brilliant helped expand my knowledge. Brilliant teaches thousands of lessons on STEM subjects with new interactive classes added monthly. If you are interested in learning more about the universe or developing skills, why not check them out by clicking my link https://brilliant.org/astrum in the description below. Everything they have to offer is free for the first 30 days, and the first 200 of you will get 20% off Brilliant's annual premium subscription. Thanks for watching. If you missed the first Oumuamua video, check it out here. And thanks to my patrons and members for your support. If you want access to these perks and have your name added to this list, check the links below. All the best, and see you next time.